Hello, welcome to this chapter. This is Introduction to Biostatistics, and this is our first lesson in biostatistics, okay? So these are the main important concepts that you need to be familiar with by the end of this lesson. So after we've gone through this lesson together, you should be able to basically understand and explain in simple words what is statistics, what is biostatistics, what is the concept of the population, the sample, what are variables, how do we get data, how do we summarize the data that we get, and what are the measures of center and the measures of spread. So these are the main important points that you need to understand at the end of this lesson. So I just want to say this, this is the first lesson, right? This is the foundation of this biostatistics course. So it's really important that you understand these basic principles because obviously these form the foundation for the different concepts that we're going to learn later on. So if at the end you feel like there's some concept that is still unclear to you, or you would like me to explain it further, please do send me a message on WhatsApp and I'll be very happy to have a class with you and explain it more and give you more examples if you need that, okay? All right, so the first concept that we need to talk about is statistics. So in general, what is statistics really? So statistics just deals with all of these things, okay? So statistics is really all about collecting data, organizing the data that we've collected, analyzing the data that we've organized, and then basically telling a story or interpreting the data that we've analyzed. So I'm going to say it again. All of this basically make up the concept of statistics. So statistics is all about collection of data, organization of data, analyzing the data, and interpreting the data. So how do we collect data? Obviously, when you do research, right? There are different things, different characteristics that you measure. And when you measure these characteristics, that's where you get data from. How do you organize the data? This is dependent on the researcher. So there are different ways to organize the data that we have. But the main point of organizing data is because you just want to put the data that you've collected in a way that makes sense so that it's easy for you to go through it, or it's easy for you to present this data to someone else. So you just want to keep things tidy. You want to organize the data that you've collected. So after collecting data and organizing it, well, the next step is you need to analyze the data that you collected, because the whole point of collecting data is we actually have a question in mind. And this is the reason why we did the research in the first place. So when we do research and we collect data, we need to analyze the data that we've collected so that we'll basically understand what this data is telling us, or what seems to be happening based on this data. So after you've analyzed the data, the next step is you need to interpret this data. So basically, interpretation of data is, are you able to make a conclusion based on the data analysis that you've done, or are you able to have a better understanding or maybe tell a story based on the data that you have? Or are you able to make some predictions, based on the data that you have? So this is all under interpreting data. Like, we want to basically understand and be able to make conclusions or interpretations or predictions based on the data that we have. So this is about statistics in general. It's all about data, collecting it, organizing it, analyzing it, and interpreting it. Okay, so this is statistics. Now, where does biostatistics come in? So if you look at this word, you can see it's basically just statistics over here and then bio in front, right? Bio is the study of life, like you've heard of biology and biochemistry and bioinformatics. This is all study of life in different aspects. So this is biostatistics. It's basically applying all these concepts of statistics to the field of scientific research or to the field of medical research. So really, this is what biostatistics is. So once you've understood what is statistics in general, biostatistics is just the application of the concept of statistics to scientific research or to medical research. Okay, so these two concepts are pretty easy, and this is like just the basic thing that we need to get out of the way first. So the next concept that we need to understand is what is a population and what is a sample. So I'm going to explain this with an example, and I'm going to use this image to, to make this clear. So a population is basically every single person in a particular region. Okay, so this is a very basic definition. So for example, think about the state of Qatar, right? We are in Qatar, so if you can imagine every single person that lives in Qatar, they basically make up the population of Qatar. So I have this drawing here, and I have the big circle, and I have the little circle. But right now, I want you to just focus on the big circle. So the big circle basically shows you every single person in that region at that time. And in this example that we're using the example of Qatar. So let's just imagine here is Qatar. Qatar is the big circle. So all of these people you see in the big circle, these people all make up the population of Qatar. So when we do research, most of the times we're interested to find out something about a population. So for example, if I'm a scientist, I could want to find out what is the average blood pressure of everyone in Qatar. So this is the research question that I have. What is the average blood pressure of all of these people? This is a good question to have, and this is a good research to do, but it's not really easy to do research on whole populations at a time. Why? Just think about it like practically. So for example, in the state of Qatar, just for example, the whole population might be around 3 million people, right? So no one really has the time or the resources to do research on 3 million people just to answer a research question. So the issue is, most of the time, researchers are not able to carry out research on whole populations because it's just not practically possible. There's just too many people to study, right? So what do we do in that case? Well, what we do is, since we have this population and we cannot study everyone in this population because there's too many people, how about we just take a few people, right? So whatever research we wanted to do on the whole population, we're going to do it on these guys, this smaller group of people that we took from the big population. So why do we do this? We do this because, number one, when we take a smaller group of people, it's easy for us to do whatever we wanted to do on that smaller group because it's just less people. So we have enough time to conduct the research on these guys, and we have enough resources to also do the research. Okay, so this smaller group of people that we've taken from the larger population, this smaller group, this is called as the sample. Okay, so this smaller circle right here, we just brought it out. This is what the sample is. So a sample is just a smaller group of people taken from a larger population. Now remember, why do we need to take the sample in the first place? We need to take the sample because most of the time, it's just not possible to do research on the whole population. So this is the very basic idea. So now that we're talking about the sample, we need to understand one important thing about the sample, and that is, what type of sample do you have? We're going to talk about this a bit more in the next slide, but I want you to know about what a representative sample is. Okay, whenever you take a sample from a population, you need to make sure that your sample is representative of the population. So what does it mean, representative sample? The easiest way to describe this is try to take a sample that looks like your population. So I'm going to give you a scientific example, but let's just use, a kitty example first. When you look at this big population, you can see there's all of these people in this population, and this population has different types of people. Like we have people who are light blue, we have people who are dark blue, we have people who are green, who are, I don't know what color this is, and we have people who are light brown, and we have people who are dark brown. So basically there's different kinds of people in this population. So if you want to take a sample, you need to make sure that you also have different kinds of people in the sample, just like you have in the population. So when this happens, we say that the sample you've taken is representative. So basically this sample represents this population. Okay, another way of saying it is that we can say that basically the sample looks like this population. And this is very important. Why is it important? Because remember, initially, we actually had a research question for the whole population. But because we couldn't study the whole population, this was the reason why we took the sample. So whatever result we get from the study we do on the sample, we actually need to generalize it back to the population because our main research question was for the population. Okay, so in order for us to be able to do this generalization, this sample needs to be representative. If this sample is not representative, then we cannot generalize. So just imagine if we took only the blue people in the sample and then we got a result. We cannot really generalize the results we got to this big population because in this population, there's different types of people, not just the blue people. So I hope that makes sense. Right, so this is about the population and the sample, having a representative sample, and then being able to generalize the result back to the population. So I use the word generalize the results back to the population because this is an easier term to imagine, but there's a more scientific term. This is called statistical inference. So statistical inference is basically when you generalize the findings you get from the sample back to the population. But remember, we can only make statistical inference if our sample is representative. So in the more scientific example I wanted to give you is if this big population is Qatar, and obviously we know that here in Qatar, we have different kinds of people, right? We have babies, we have children, we have young adults, and we have elderly people. And then when it comes to races, we also have different races. Like we have Caucasians, we have Africans, we have Asians, right? And when it comes to skin color, also we have different types of people. We have Black people, white people, and brown people, stuff like that. So the whole point is we have different types of people in this population. If you want to do research on a sample from Qatar and you want it to be representative of the population, then you have to take care to include different types of people in your sample. So this is just what we've talked about before. And the reason we want to do this is because we want our sample to be representative. And remember, why do we need the sample to be representative? Because we need to make statistical inference, all right? So I hope this concept is clear now. Then the next thing we need to learn about the population and the sample is about the population parameters and the sample statistics. So the population parameters, these are basically characteristics that describe the population for us. So for example, there are three important parameters that we need to know about the population. Again, population parameters, these are characteristics that describe our population. So if this big circle is a population, the first parameter we could be interested in is population size, like how many people are in this population. So this is big N. This is what big N stands for, is the population size. Now, the next parameter we could be interested in is population average, right? So this could be average of anything. So for example, there's all of these people in Qatar. I could be interested to find out what is the average blood pressure of people in this population, or what is the average height of people in this population, or what is the average weight of, so this average could be anything, right? So this right here, this is mu, okay, mu, population average. Then another parameter we could be interested in is population standard deviation. This is sigma, okay? We're gonna talk about standard deviation a bit later on when we talk about the measures of spread. But again, what do I want you to know? Population parameters. These are the characteristics that describe the population for us. Okay, so just as we have population parameters, we also have kind of like the same thing, but for the sample. So here for the sample, it has another name. It's called as the sample statistics right here. So what are sample statistics? Those are basically characteristics that describe the sample for us. So for example, if this is my sample, I could be interested to find out what is the sample size. Okay, so how many people are in this sample? So here, this sample statistic is small n. Now remember, for the population, it was capital N, but for the sample, it's small n. But this is, the sample statistic, sample size. How many people are in this sample? Then another sample statistic we can have is the sample average or the sample mean. This is X bar, X bar. So this is the sample mean. So for example, what is the average blood pressure of people in the sample? What is the average height of people in the sample? What is the average age? Average of anything for the sample. This is X bar. Then the next sample statistics, this is S, okay? So this is the sample standard deviation. Just like we had the population standard deviation, we have the sample standard deviation. And again, this is going to make more sense to you when we talk about the measures of spread. So population parameters on this side in blue, sample statistics on this side in pink. Now remember, the whole point of taking the sample is because we could not study the population. So whatever we get from the sample is really trying to give us an estimate or tell us about what is happening in this population. So the reason I say this is very important because usually when we want to do research, we're usually interested in a particular average about the population. So most of the time we could want to find out, for example, what is the average life expectancy in Qatar? What is the average age in Qatar? What is the average this? So we usually are interested to find out a particular average about a population. So usually we want to find out what is mu. So we know that mu exists for this population, but because there's too many people in this population, we don't know what mu is. So remember, this was the reason why we took the sample, because we know that we can do research on the sample and then find out the average for the sample. So really, we can find out X bar. But remember, the whole job of X bar is to give us an idea of what mu could be. So the whole job of X bar is to give us an estimate of mu. So this sample statistic is giving us an estimate of this population parameter. So this is a very important concept for you to have. When we do research and we get X bar, we actually want to get an estimate of mu by using this X bar, okay? So I hope this part is clear so far. And basically this slide is talking about everything that we've talked about, the population parameters, which are characteristics that describe the main population, like big N, mu, and sigma. And then the sample statistics, which are the characteristics that describe our sample, such as sample size, small n, X bar, and the sample standard deviation. Now remember, sample statistics give us estimates of the population parameters, just like mu help us to get an estimate of, just like X bar help us to get an estimate of mu. Okay, so these are very important basic concepts that we need to have. So when we talked about the population and the sample, we actually spent some time talking about representative sample. And remember, this is just a sample that looks like our population. And remember why this is important because we need to make statistical inference, or we need to generalize our findings back from the sample to the population. So this is the reason why we needed our sample to be representative. So another word for representative is unbiased. So you want to have a sample that is representative or unbiased. Okay, so this is just different terminologies, but for the same concept, right? So I already gave you a different example, but here this is just another example. So for example, if in this population, this big population, remember this was Qatar in our example. And if, for example, in the population of Qatar, we have 60% non-Qataris. This is just how it is. And then we have 40% Qataris. This is just how it is, right? So this is how the population is naturally. When you take a sample, you also want to try your best to have a sample that consists of 60% non-Qatari and 40% Qatari. Why? Because you're just trying to make your sample look like your population, remember, so that you can make statistical inference, right? So this is just more explanation on the same concepts we already talked about. Okay, so the next concept we need to understand is about variables. So what are variables in research? Variables are basically characteristics that are being measured in research, right? So I gave you the example before. If, I'll just draw it, if this big circle was Qatar, and I wanted to find out what is the average blood pressure of people in Qatar, right? But then remember there was too many people, so I'm just going to take a sample of, let's say, 500 people, okay? So in this sample of 500 people, I'm going to conduct research and try to find out what is the average blood pressure of these 500 people so that I can generalize my findings back to the population. So in this 500 people, I need to measure some things, right? I need to measure some characteristics which are unknown. So those characteristics that are unknown that I need to measure, these are called as variables, right? And variables differ. Variables can be different for different people because obviously everyone is not the same. So in my sample, I can measure variables such as age, right? So age could be different for these 500 people. Some people might be young, some people might be old. I could also measure gender, right? Some people might be males, some people's will be females, right? I could also measure nationality because there are different people in this country. So some people might be Qataris, some might be Palestinians, some might be Iraqis, some might be Nigerians, and so on, right? So these are examples of some variables that we could measure when we're doing research. And of course, I can also measure blood pressure, and this would also be different for different people. So variables, these are the characteristics that are being measured in research. Now, remember I have a sample of 500 people. So when I measure all these variables, I'm basically going to get data like all over the place because I have 500 people and I'm measuring the age for 500 people, the gender for 500 people, the nationality for 500 people, and the blood pressure for 500 people. So that's a lot of data. So at this stage, I've collected the data, but then remember, we need to tidy this data. We need to organize it. And one way we can organize it, we need to summarize it, right? So when you summarize the data, it basically makes it easy for you to look at. And it also makes it easy for you to present it to someone else. For example, if you're going to write a paper or you're going to make a presentation. So we need to summarize the data that we get when we measure all these variables. So there are two important ways we can summarize the data. We could use graphs or we could use numbers. And this actually makes it very easy. So for example, summarizing with graph is, if we're going to talk more about graphs, obviously, but for example, if I have 500 people, right, and I show you a graph and I tell you, okay, in this 500 people, this much were Qataris, right? This much were Lebanese, this much were Americans, this much were British. So even though like there's a lot of data here, this graph just summarizes, like it's easy to look at, it's like clean, and it just makes it simple for you to see, okay, it seems to be a lot more Lebanese people in the sample than American people, for example. So looking at this graph helps you to make some quick interpretations. So this is one of the reasons why it's good to have graphs that can summarize the data. And also, for example, we can summarize the data using numbers. So for example, one of the variables that we can collect is age. So imagine if I have 500 people and basically I've collected the data on the age for these 500 people. So that's just numbers all over the place. Well, I could summarize this using a number and tell you, okay, one of the measures that summarizes the age is the average. So I could tell you, okay, the average age in this sample was 52 years old. So I'm just giving you one information, one summarized information. So this basically summarizes the age for all these 500 people. So again, this is easy for you, it's easy for me, it's easy for everyone to just make sense of the data that we collected. Okay, so this is about variables. So just to summarize, variables are the characteristics that we measure when we're doing research. When you measure variables, you get data, right? And obviously variables can be different for different people because everyone is not the same. Now, when you get data, you're gonna have data all over the place, especially if your sample size is large. So it's just good to summarize the data that you have. And two ways to summarize the data is either you use graphs or you use numbers, right? The whole point of summarizing data is just to keep everything clean and tidy so it's easy for us to analyze and interpret. Okay, so now we're just going to quickly talk about, variables some more. We're going to talk about variables, right? So now that we know what variables are these characteristics that we measure. We need to know that there are two types of variables, right? Whenever you're doing research and you need to measure variables, there's two types of variables that you could measure. The first one is called as categorical variable, right? And then the second type is called as numerical variable. So the easiest way to understand this is whenever you're measuring a variable, that variable you're measuring is either a number, numerical, or it's not a number, but it's something that is in categories, categorical, right? So even before going through this chart, I'm going to give you an example, right? So for instance, again, this is my sample, I take a sample of 500 people, yeah? And one of the variables I measure for this 500 people is age. So age is a number. So I'm going to have numbers for all these 500 people. So I know that, for example, age is an example of numerical variable, right? Because age is going to be a number. But for example, if I'm measuring the nationality, right, of these 500 people, nationality is not really a number. Like, you cannot tell me you come from country number 2. It doesn't make sense. It's either you come from Qatar, or you come from United States, or you come from Nigeria, or you come from Lebanon, right? So this is not a number, but it's in categories, basically, like, for example, you're either Qatari, or you're American, or you're Lebanese, or you're Nigerian. So find a category and you must fit into one of the categories. Now remember, this is a very basic example just for you to understand. So the whole point is variables can be broadly divided into these two types. So now under the categorical variables, for example, you can see that there are different categories, or there are different groups. So these are the different groups. We can further divide the categorical variables into two types. We have nominal categorical variable, and we have ordinal categorical variable. Okay, so on the next slide, I'm going to tell you, with examples, what do these mean? Nominal and ordinal, but these are types of categorical variable. And then under nominal categorical variable, we also have a specialized example, which is the binomial. So just hold on for a second, and I'm going to give you an example. Now, the numerical variable is also further classified into two types. We have continuous variables, and then we have discrete variables. So this is just the basic classification. Now, let's understand it using examples, right? So I hope you can have this image in your head, where we have variables that are first classified into categorical. So categorical variable is going to be these two, right? So these two are categorical variable, and then numerical variable is going to be these two. So if the variable you're measuring is a number, it's under numerical, right? If the variable you're measuring is not a number, it's under categorical. So this is what's happening. Now, we said categorical variables are further divided into two, nominal and ordinal. So I've just used these little illustrations to make it easy for you to understand. Now, remember, nominal is just categories, like different groups. So for example, here we have one group, we have another group, we have another group. So we have different categories. So for example, here, nominal categorical variable actually means that all of the categories don't have any order to them. They're just different groups, and you can fit into any of those groups. So an example here is nationality. So if, for example, this yellow box means Qatari nationality, and this orange one means Nigerian nationality, and this blue one means British nationality. So when you're measuring variables, like the people in your sample, they could either be Qatari, or they could be Nigerian, or they could be British. But these are just categories or groups that don't have any order to them. So this is what nominal categorical variables mean. Now, under the nominal categorical variable, I want you to understand a special type of nominal, which is called as the binomial, right? I want you to know also there's another word you could see for the binomial. Sometimes it's also called dichotomous, right? So this is just, this binomial and dichotomous is talking about the same thing, but it has different names. So when you look at binomial, bi obviously means two. So binomial categorical variable is just telling you that we have only two groups, like there's only two groups, because bi, there's only two possible groups. So an example of binomial categorical variable is gender, right? Because when you're measuring gender, there's really only two choices. You're either male or you're female. There's really no other box, right? It's either you're male or you're female. So this is a good example of binomial categorical variable. Another one is, now when we're talking about medical studies and you're trying to do some type of research, you could want to measure something like dead or alive. So there's only two possible categories. So the whole idea is if the variable you're measuring has only two possible categories, it's an example of it's nominal, yes, because the categories don't have any order, but it's binomial because there's only two possible categories, okay? So this is about the nominal categorical variable. Now coming to the ordinal, like look at the name, ordinal, order, right? So now the groups or the categories actually have an order to them. So this is the reason why I've drawn this like this, where you can see this is at the lowest possible level. This is at a higher level. That's another higher level. So we have groups, yeah, but we have order to them. They're not all on the same level. They're at different levels. So this is called as ordinal categorical variable. It's ordered categories. So for example, if you're doing research in a university and you have a sample of 200 students, obviously all the 200 students might be at different levels in the university. Like some of them might be in the first year, some might be in the second year, some might be in the third year. So obviously first year students are not the same as third year students because third is higher than first. So this is an example of ordinal categorical variable where the variables have an order to them. Another example off the top of my head is if you're doing some type of medical research and you want to study the pain level, right? Pain level. Some people might have zero pain, like no pain. Some people might have manageable pain. Some people might have intense or excruciating pain. So here you see also pain is not at the same level. There's like orders to this. We have no pain, manageable pain, excruciating pain. So this is what the ordinal categorical variables are. Now, coming to the numerical variables, we have the first one, the first subdivision is continuous numerical variable. So when you think about, something like this, this basically means something that doesn't have an end. Like you can't really count all of it. This is infinite. Okay. So for example, if you're measuring someone's weight, I could tell you, okay, I weigh 60 kg, and that makes sense. I could also say I weigh 60.2 kg. Yeah, it still makes sense. I could also say I weigh 60.259 kg. It still makes sense. So this could be infinite, right? You can't really count all of it. So this is why we put here for numerical continuous variable. There's a variable that has infinite count. So if you put a decimal and you keep going, it makes sense because it's a continuous numerical variable. Now the other type, this is discrete, right? So discrete, it's a numerical variable, means yeah, it's going to be a number, but it's discrete means it's actually finite, like we can't actually count it. So for example, if you want to tell me the number of children you have, if you tell me I have one child, it makes sense to me. If you tell me I have 4 children, it also makes sense to me. But if you tell me I have 2.3 children or I have 2.36 children, this doesn't make sense because children are not infinite. Like you cannot tell me 0.36. There is no 0.36 child, right? So it's either you have one child or you have 4 children. You could also have 2 children or 3 children, but not 2.3. So it has to be a whole number count. This is what the numerical discrete variable is talking about, okay? So I hope that makes sense, and this is really what we need to understand about the variables. Now, still on the matter of variables, we need to know about, a special type, and this is called as derived variables. So the word derived just means that you get something from something else. Okay, so a very important or a very easy example to give here is BMI. I hope you know what BMI means. This is the body mass index. So basically, BMI is the number that you calculate, and it basically helps you to know what category you are. Are you, let me get my pen. So when you calculate your BMI, it basically lets you know if you're underweight, right? Underweight, if you have a normal weight, if you are overweight. So let me just write it. If you're underweight, if you have normal weight, if you're overweight, or if you're obese, right? So you will understand what category you belong to when you calculate your BMI. So for example, if your BMI is greater than 30, you would know, okay, you're obese. If your BMI is, for example, 25 or less, you would know, okay, you're normal. If your BMI is like greater than 26, for example, you would know, okay, you're overweight, but you're not obese. So how do we get the BMI in the first place? The BMI is really calculated using someone's height and someone's weight. So we know that height by itself, this is a numerical variable, okay? More specifically, this is a continuous numerical variable, okay? Now, what about weight? Weight is also a numerical variable, and also, more specifically, this is a continuous numerical variable. So, but when we use the height and we use the weight, from these two variables, we can make another variable, which is called BMI. So as you can see, BMI, this variable has been gotten using this variable and this variable. So this is what the derived variables are. So just to be clear, I'm not saying that BMI is the only derived variable that we have. No, the main point I want you to understand is if you can get any variable from another variable, that variable that you're getting from another variable is derived variable. This is the point, okay? So I hope that is clear. Now, the next thing that we need to know about the variables is about the 4 scales of measurement. Okay, so this page, has a lot of words, but, I don't really like talking with too much words. So I'm going to go to this page where everything is in a table. But I want you to know that everything I'm going to say here is obviously explained on this page, right? So variables that we can measure, they're actually variables that we have, they can actually be measured on 4 different scales. Okay, so the different scales of measurement that we have, 4 of them that you have to know, is the nominal scale, the ordinal scale, the interval, and the ratio scale. This should kind of make sense to you because I hope you can see that these two, we're actually talking about the categorical variables, right? And these two, we're actually talking about the numerical side. So, but this is just a more, a different way to actually look at it. So when we're talking about the nominal scale of measurement, we're basically saying that this is just a variable that is named. So it just has a name. So for example, gender. Gender is a nominal variable because all we have is the name of this variable or the different categories, right? But when we come to the ordinal level of measurement, now there is another step, right? In addition to being named, ordinal level of measurement also has an order, like we've already talked about. So just like I explained before, this is going to be pain level. So pain level is obviously named, yes, but then we know that now there's an order to it. You could have no pain, you could have moderate pain, or you could have excruciating pain, right? So there is an order to this level of measurement. But one thing about the ordinal level of measurement is it only has these two things, the name and the order, but there is no equal interval between the variables. So let me just write this so it makes a bit of sense. So what we're talking about is having no pain, right? This is the first level. Having moderate pain, this is the second level. And then having excruciating pain. Excruciating pain is just like, this is the worst pain of your life and you feel like you're about to die, right? So this is ordinal because it's named, yes, and it has an order to it. But really, there is no equal interval between them. Like, we cannot really say that the same amount of distance between moderate pain and no pain is the same amount of distance between excruciating pain and moderate pain. No one can say that. So when it comes to the ordinal level of measurement, all we have is a name and an order. But the next level is interval, right? So the interval now adds this next level. So we have name, we have an order, and now we have equal interval between the variables. So think about temperature, for instance. Temperature obviously has name and is ordered because, you know, we can go from, like, for example, we can go from -1 degrees to 30 degrees. Yeah, so there is an order, but there is equal interval between the variables. So it's like a degree apart. So we have -1 degree, we have 0 degree, we have 1 degree, we have 2 degree, we have 3 degree. So there's equal interval between the different variables. So this is present in the interval level of measurement. Now, the next level or the last level, but then the thing about the interval level is it does not have a true 0 point. Like, there is no place where it really stops. Like, we cannot say that 0 degree is, you know, this is the bottom. No, because we know that there is -1 degree, which makes sense. There is even -40 degrees, which makes sense. So as you can see, there is no true 0 point in this interval, right? So again, what do we know about the interval? It's named, it's ordered, there's equal interval between them, but there is no true 0 point because, you know, it goes on both sides, positive and negative. But then the next level of measurement, this is the last one, this is the ratio, okay? So as you can see, I hope you can see what is happening. Like, there's things that are being added that the other things don't have. So for the ratio, it is named, yes, it's ordered, there is equal interval between the variables, and this one has a true 0 point, right? So for example, weight, right? Weight is named, weight is ordered. There's also equal interval between them, but there's a true 0 point because we cannot really say that something weighs -21 kg. You know, this doesn't make sense to us practically, right? So 0 is 0. It doesn't have a weight. Okay, so I hope that makes sense. This is about the scales of measurement that we need to know. And again, everything has been described in the slide with so much words, right? So we've talked about variables in depth, and we know that these are the characteristics that we measure when we're doing research. And we know that when we measure the variables, we get something back. So what we get back is data. And just like we've talked about, depending on our sample size, we can get data that is just all over the place. So we need to basically tidy this up and summarize it so that it's easy for us to read and make sense of it. And it's also easy for us to present it to somebody else. Now, the two important ways we can summarize the data that we get is by using graphs or by using numbers, like we talked about before, okay? So when we get data, just like variables, really, data can be qualitative. So imagine you're measuring a variable like nationality. The data you're going to get from that is qualitative data because remember, these are categories. You know, this is just about a quality. It's not going to give you a number. it's just going to give you a quality. So this person is Qatari, this person is Nepalese, this person is Kenyan, and so on. So there are no numbers. If there are no numbers, this is qualitative data. And obviously, we're not really going to have a unit because, it's not numbers. But then if the variable that we're measuring is numerical, for example, we're measuring age or weight or height, then the data we get is going to be quantitative. Okay, so for example, if you're measuring people's age, this is quantitative data because it's numerical, it's numbers, right? So just like we've talked about, we need to summarize the data that we get. We can summarize it using graphs or numbers. So usually the data summary type that we're going to use depends on us as the researcher, depends on what we want to show, but it also depends on the type of variable that we have. Okay, so these two things, our intention and the type of variable, this is going to lead us to select the correct summary. It's either we use a graph or we use numbers, okay? So for example, if the variable type that we have is categorical, then really we can use these different types of graphs. Like we can use a bar chart, just like I talked about before. Like if I have, this is my sample, if I have a sample of 500 people, yeah, and I measure all their nationalities, I could use a bar chart just to show you the different categories. So these are the categories, these are the British, these are the Syrians, right? These are the Indians. So when I have a bar chart like this, I can also, this is the graph, this is the graphical summary bar chart. I can also tell you the number, right? How many people are in this group, how many in this group, how many in this group, how many in this group. I could also tell you the percentage, right? Like what is the percent of people who are Qataris? What is the percent of people who are Americans, for example? What is the percent of people who are Syrians? Or what is the percent of people who are Indians? So I can also give you this information. Then, like we're going to talk about later, we can, also give you risk ratio and odds ratio. But this we're going to talk about later. But what I want to tell you is, depending on the type of variable I have, for example, categorical nominal, I could use a bar chart. For example, I could also use a pie chart, right? So I hope you know what a pie is, like the thing that we eat. So a pie is usually round. That's not very round, is it? Let's try again. Well, yeah, we're just gonna use this. Well, the point is a pie is usually round, right? But then out of this whole, it basically tells you the different categories that make up the whole, right? So if this whole is nationality, right? Now we can tell you, for example, these are Qataris, right? These are Iranians, right? These are Americans, and these are Syrians, right? So this is what a pie chart looks like. Like it tells you what are the components of the different wholes that we have, right? So this is, for example, what a pie, and as you can see, a bar chart or pie chart works nicely if we have categorical variable, right? And just like, just like we talked about here, I can also tell you the number of people in this component. I could tell you number of people in this component or here, or more importantly, like it's usually done, I can tell you what is the percentage of Qataris out of the whole, what is the percentage of Iranians out of the whole, what is the percentage of Americans out of the whole, and so on. Okay, so this is about the bar chart and the pie chart. Now, when we have, so this is for categorical nominal. When we have an ordinal categorical variable, now, technically you could use a pie chart, right? Like there's no rule that says that you cannot choose a pie chart. You could, but what is the best way to show ordinal variable? Well, it's really gonna make more sense if you have a bar chart, because when you show the bar chart, it's easy for us to see the trend, what is happening, right? And see this different, this order that it has. So for categorical ordinal, we would go for bar chart more than the pie. So this is for if you have categorical variables, right? These are the different graphical summaries that we can choose. Now, what about if we have numerical variable, only numerical, or if we have a mixture of numerical and categorical? Well, what's going to happen is if we have a numerical and categorical variable, then we could choose from these ones, right? We could use a histogram or a box plot or a dot plot or a scatter plot. Now, some students ask, okay, which one do we choose when we see a question? What is going to guide you is what is the question asking you about? Because all of these different graphs really show you different things. So for example, a histogram looks like this. A histogram is here on the x-axis, right? We actually have different classes, right? Here on the x-axis. And then on the y-axis over here, we have some sort of category, right? So a histogram is basically going to show you what are the different classes that you have, right? Like this. This is usually what a histogram looks like. So histogram, first of all, shows you what are the different classes of variable that you have, and then what is the frequency of each class. See, these are the frequencies of each class. And then it also tells you how big is this class of variable, right? So this is what a histogram looks like. And another thing about the histogram is it's able to show you the spread or the shape of the variable, okay? So histogram is basically useful when we want to show the different classes of categories as well as the frequency of each category. And this is done using bars that basically touch each other. So all of these bars are touching each other. This is what a histogram looks like, okay? And then what about the box plot? Well, a box plot is also used when we have a numerical and a categorical variable, but a box plot basically looks like this. Okay, so for example, here, I'm going to draw my box, right? So this is the box. We're going to talk about this a bit more, obviously, but this is what the box plot looks like, right? So here, usually we're talking about one categorical variable. So this categorical variable could be maybe age. Oh, no, sorry, I don't want to use age. Yeah, I actually can use age. So the variable, not categorical, so the variable that I want to talk about is age. So this box plot is basically going to show me what is the minimum age recorded. And then what is here, we have maximum age recorded. And then what is the median age recorded. We're going to talk about the box plot and get to understand what all of these different lines mean, but it can also show me some other information. For example, this is called as Q1, this is called as Q3, right? And I know that Q1 shows me the first quartile, Q3 shows me the third quartile, Q2 shows me the median, and so on. So you don't have to understand all this right now, but I just want to tell you that when we're using a box plot, we basically, first of all, want to see the minimum value, maximum value, the different quartiles. We can also see median, and more importantly, box plot is going to show you if you have any outliers. Why? Because the outliers are basically going to either be, in the maximum side or in the minimum side. But the issue is if you have outliers, then you're going to see tiny stars that are away from the box plot. Okay, so what I want you to know about the box plot is it can show you all this information, the quartile, the percentiles. the maximum and the minimum value, the median, as well as any outliers if you have any. Okay, so this is the box plot. Then the next one is the dot plot, which I've also explained in the next slide. And more importantly, scatter plot. So I'm actually talking about, the histogram, the box plot, and the scatter plot, because these are the ones that are usually asked about. So scatter plot basically looks like this. Okay, so you have a graph. This is a y-axis, and this is the x-axis, right? So you have data. So obviously, this is the graph. This is the plot. So now you have data that is scattered on this plot, right? But scatter plot is important because when you look at the way this data is scattered on this plot, we can basically try to see if there is any trend or if there is any relationship between this x variable and this y variable. So the thing about the scatter plot is this x variable has to be a numerical variable, and this y variable also has to be a numerical variable. So we basically want to see if there is a relationship between this numerical variable and this numerical variable. And the way that we're going to do it is we look at the way the data is scattered on the plot and see, is there any trend, right? So for example, here, there seems to be an upward trend, right? Because if you look at the way this data is scattered, it seems to be going like this. So what we can say from this scatter plot is, yes, there seems to be a relationship between this x variable and this y variable. So for example, this x variable could be, this could be weight, and this y variable could be, for example, height. So if you have a scatter plot like this, it tells you, yes, there seems to be a relationship between weight and height. You can also have a scatter plot where, this is a numerical variable, this is another numerical variable, and you have data that is scattered like this. So when you look at this data, you can also see, okay, there seems to be a trend, the data seems to be trending downward. So this also tells you that there is a relationship between x and y. Here, we have a positive relationship because as you can see, when x is increasing, y is also increasing. So there's a positive relationship. We're going to talk about this more when we learn about correlation and everything. So here we say there's a positive correlation, but don't worry about that. And here there is a negative relationship because as you can see, as x is increasing, y seems to be decreasing. So there is a negative relationship or negative correlation. So again, don't worry about all these big words. All I want you to know is we use a scatter plot when we're trying to see if there's a relationship between two numerical variables. Okay, so this data summary part, you're welcome to watch this part again if you need to understand it better. And remember, if you have any questions, I'm always happy to talk to you on WhatsApp or to explain to you again in a live class. Okay, so this is just everything that I've talked about. I put it in writing for you to basically know how to describe it by yourself, right? So this is a good place to start because we've already studied for an hour, right? In the next video, we're going to talk about descriptive statistics. So this first part, we basically covered the foundation and the basics, what is statistics, what is biostatistics, what is a population, a sample, what are population parameters, sample statistics. Then we talked about variables, the types of variables. We talked about the scales of measurement. We also talked about data. Data can be qualitative, it can be quantitative. How do we summarize the data? We can use graphs, we can use numbers. So we've talked about all of these things. Now in the next video, we're going to start talking about descriptive statistics and you would understand what that is. Okay, so do remember to practice questions after each video. And please, if you have any questions, any doubts, something you want to clarify, I'm always happy to take your questions. Okay. So that's it.